Yeah, yeah, we can try because I also don't know one part of it actually. Yeah. So there is this function fx. Yeah, don't be afraid by the question. You're not going to be you have to just understand it step by step what it is, and then it's easy. Then you can solve it actually. So this n goes from 0 to infinity. Okay. And so let's say it is this. Okay, so first question would be uh, find domain of x, domain of f. Okay, so what do you think is the legal domain of this? So before that, if you ask what does this expression mean, it just means that for every x, right, for every point x naught, we evaluate this series at that point x naught, right? And if the answer is finite, then obviously x naught is, then we keep x naught in the domain and we associate it to it that value of that series. Okay. Is this fine? Like what the function is meaning? Yeah. At each input x naught, for example, at half, you will evaluate this series at half, and provided everything is positive, but then if it has a finite sum, then you would say that that is the limit. Okay. I hope the question makes sense. Hmm? Yes. That you have to figure out, right? That's exactly what you have to figure out. For which values of x does this series converge? No, for this you will not. That's the point of this question, that you will not need any hi-fi convergence tests. So you can start with your usual, just start with x equal to 1, x equal to half, and just see what happens, and you will get an idea. You'll be able to make a guess. And since this is an exam question, so some, yeah, reasonable guess will work. Yeah, just try this. I'll just be back. Yes. Say. E power x should be greater than equal to 1. So you are just saying that x is greater than or equal to 0. That's it. Perfect. That's correct. So you can prove that. Yeah. So the domain of x is 0 to infinity. Okay. So just for checking, it at 0 it is certainly convergent, right? At 0 it just becomes this function, and this is a classic converging thing, right? You may say this needs a convergence test, but it's fine. You can work that out. This is a convergence series, right? And when x becomes greater than 0, this actually decreases, actually lesser, right? It's actually this is actually bigger than e to the power minus half, let's say. I mean, as you said, right, it's sort of less than 1. So it's even better. And for x less than 0, it doesn't converge. You can prove that, right? That also you need to just show, right, that for x less than 0, it doesn't converge. And you should do that. So please do those things. If you don't do, then you won't know. Yeah. So this is fine. Now, now the question is, and again, this is going to be elementary. I'm not asking anything that requires, yeah. Does the right derivative of f at 0 exist? I'm only asking at 0. And right derivative, left derivative doesn't make sense. Again, take some time and think. Now, I guess is the first part clear, the domain of f? Yes. So just you have to put some values and then you would know what is happening. So at least that part is done. Now this one is maybe, yeah, depends on how comfortable you are with the notation. Yes, yes. Yeah, but I will say that only will work. Okay, means that only is enough. So you take like FH, then you take F0. But let us see. Everything can be done from definitions, but how easy it is, we don't. So take this. Now let us see. So we write this summation. This infinite sum. And then you write this. Okay, at a general X, if you're trying to do, yeah, then also it, I suppose, will not should not be impossible, but we don't have to do that. So we are just going to do this. So now here is the question. So why can we do this? Why can we write like this? This one has to prove actually. Right? Obviously, we are not writing the limit. But you see here, what is happening is that I am saying that an plus bn, this is equal to an plus bn. But this is nowhere it is said that this is true. It doesn't follow from the definitions. Right? It follows in the finite case, but for an infinite sum, this is a very different thing, right? Just imagine, right? This is the limit. This is the limit of some sequence. This is the limit of some other sequence, and this is the limit of some other sequence, right? But it should be true, and so it is true. Okay. So this you should try to prove. Right? This is kind of a homework. You should try to prove this. That at least when uh, all the terms are positive, it is true. And when all the terms are positive, if there are positive and negative terms mixed, it's actually not true. Okay, you can try that out. It will not be true. Okay, you cannot just separate a series in this way. Okay, yeah, so you can think about this. But in this case, we can do because the terms are positive. And now, what about this? What about this? What do you think happens to this? Any idea? So what we are looking at is something like this. H, and this is and so on, right? Goes on. And so there is first a limit that is taken with respect to n, meaning that n tends to infinity, right? Because this is simply the limit of partial sums. And then we have limit h goes to 0 from the right side. Okay. So again, as a homework, try to show that this is actually minus infinity. Okay. Or what? How do you show something is minus infinity? Just show that given any number n, given any m, this can be made smaller than m. Right, given any m, given minus 100, give yourself minus 100 and just show that this can be made less than minus 100. Okay, and so the limit will be minus infinity, and so the answer will be no. But this I would want you to first try. So we are not doing everything, but to try the things. And then you can try to show that at every other point, actually the function is differentiable. Okay? That is also a homework. So show f is differentiable at, and hence at least if not, try to show it is continuous, right? F is differentiable, and that again you can try to follow the same process and see, right? I suppose you should at least try it, right? And see, maybe you will succeed, I think, right? Differentiable on 0 to infinity. Okay. And also take this for homework. This is basically an exercise where you become comfortable with sequences and functions. Okay. Show that f is continuous at 0. Okay, that's something that happens. It's continuous at 0. So again, just write the definition of continuity and just see f of h minus f of 0, that the denominator h is not there. Just show that that can be made small as you want. F of h minus f of 0. You don't have to compute f of 0. You don't have to compute that summation, that formula or anything. You have to just take the difference and show it goes to 0. Okay. Yeah. So just do these problems, and yeah. I had more questions, but can we discuss the last this question that I had given? I think that was an interesting question, right? Yeah. Aryan, do you remember the last day's question? Okay. Okay. No, okay. Okay, fine. You should have tried it, but I suppose maybe you didn't get the time. Boards. Okay. So let us try it a little bit. Let's try to take it a little bit forward, and then we'll see. Yeah. So what was it? It was basically, and maybe Nagesh has been doing the matrix things also. So maybe this will be nice. But yeah, we all know matrices. So A, yeah. So A is invertible. Yeah, I don't know if that is important. Yeah, that is not important, but anyway, yeah, let's not write it. Yeah, not important. So A is this n by n matrix, okay, such that for all x in Rn, okay, Ax P. I will define this. I have defined this last time, but I'll define it again. Q is equal, then show P equals to Q, and P and Q are greater than 1. Greater than equal. I mean, in your mind, you can think P is 1 and Q is 2. That I don't have any problem with that. Okay. So what does this mean? What does this mean? So X is in Rn, and so this will mean just the analog of, just the analog of the distance. Okay. And we just take the pth root. All right. And similarly, Ax is also something in Rn, right? Ax is now just something in Rn, and you can apply the same thing. Similarly, it applies for Q. So this is the P distance. You can just imagine two distance and do it. Yeah, but I will do it in an abstract way. Then you can try to, again try to write the proof in your own way, and so on. So we want to say that P is equal to Q. I mean, one thing you can notice from here, right, that this actually implies array is invertible. This condition itself implies array is invertible. Can you see that quickly? Right? It's not super important for us, but you can see that this implies A is invertible, or you can think about it, why this implies A is invertible. Okay. Right. So, but let us move on. So what was I thinking? We'll try to show this. The idea is that the distance, if you think about it, right? If you think about it, like if you just take a vector, let's take any vector, okay, 1 by 2 comma 1 by 4, right? If you take this vector, and if you take its one norm, okay, now what is it? It is just this, right? If you take its two norm, then it is this, right? Which one is bigger? Any idea? Which one is bigger? Can anything? Yeah, I think something can be said, right? So think about it, which one is bigger? For any given vector, if you take the two norm and if you take the one norm, then this is the language, okay? So you understand the definition. So which one is bigger? Hmm. Yeah, just work it out. First one is bigger, right? First one is always bigger, right? So the point is that as the p increases, the length of the vector actually decreases, right? That is what seems to be the case, right? And it's not very difficult to see. If you take a point, yeah, and this for vector x, stay in 2D, then the two length is this length, yeah. And what is the one length? The one length is actually this plus this. Is that right? Yeah, yeah. And then yes, exactly. Then this triangle inequality. So I think that is true in general, right? That as p increases, even when you make p bigger than 2, it should decrease. And yeah, I mean, you can just prove it by calculus also, right? That it's a decreasing function in p or something, right? So yeah, take p as the variable and prove it, right? That it's a decreasing function in p. That will also do it. So anyways, yeah. So that is the uh, idea we will try to use. Okay, let us see. Mm, 1 second. Yeah. So let us write it. So if you take ax, then how does it look like? It looks like a11x1 plus a12x2 and so on, a1nxn. That's the first coordinate of ax. Right? Similarly, second coordinate. Right? And like this it goes. And this is ax. Right? an1x1, annxn. This is the thing. Okay. Okay. Now if you are going to take the p norm of this, then what does it become? Obviously, you can try to do it for 3 by 3. That's what I had suggested. Then what does it become? So, yeah, certainly it would become something like this, right? I'm not writing the mods. Yeah, maybe 1 and a njxj, okay, to the power p, and then whole to the power 1 by p. Okay, right? But then you see, you understand this is the same thing. This is what the p norm is, right? But those are the coordinates, right? This is become your first coordinate. This is the second coordinate. So you take the coordinate, raise it to the power p, add them, and then raise it to the power 1 by p, right? Now we want to somehow isolate the xi's, right? We want to separate the xi's and the ai's. You understand? Because we want to compare it with the right hand side. So yeah, how to do that? We have to see. What do you do after this? On the right hand side, you have this. Yeah, we can. That is fine. But then what do you do after that? Haha. No, that's right. But that is fine. That is there. But even if I do that, then I was thinking, what will I do after that? So the right hand side is that. Okay, and but now just think of how to separate the this AIs from the XIs. Okay, so yeah, so maybe I will erase this. It's not very useful, I suppose. Okay. Yeah. So basically, if this is equal to this for all XIs, then in fact P becomes equal to Q. That's what we have to prove. So let's do it. Uh, if you look at this, right? Or maybe I'll just write it. So it is something that is Wrong. It's not correct. No problem. Okay. And then we have this raised to the power p. Now, can we say this is less than something? Yeah, now I'm thinking of something, but I doubting myself. Wait. Uh, Wait, no problem. So this is the norm A. How did I do this? So wait, so first of all, let me state so this thing is bigger than or equal to this, right? This is your Minkowski's inequality. So can we use it, right? This is a Minkowski's inequality. It is just saying that you have a vector A, right? And you're taking its P norm, just some kind of distance and some kind of distance. Then by just triangle inequality, a vector, right? So can we apply this kind of thing here? Yeah, but then it is like there is only one vector. Then it is like there is only one vector. Summations. Then yes, right. So you see the way you have to apply this is like this, right? So you let's do one thing. Let's write this in full, then it will be more clear. And that is the trick, I suppose. So look at it. A2n xn to the power p, right? And then it goes like this. And let me write the last one also. Okay. And that's why you should do this for 2 by 2 for yourself also. Right? So this is the whole expression. All right, 1 by p. Now try comparing it with this thing right here. Try comparing it with this thing. Now what happens is the following. This is going to be the first coordinate. This is going to be the second coordinate, and this is going to be the nth coordinate of some vector of one of my vectors. And what will that vector be? That vector is obviously then I'm just putting commas, yeah, and a1 x1, this, yeah, this vector, right? And what we'll do is that we will say that you will take the p norm of this vector, right? This is my vector, right? And then similarly you look at the second ones. This is my second vector, right? Okay. Yes, exactly. That it becomes the sum of those vectors, right? So, right, and then it follows, but let me just write it. So like, I'll not even write the p norm. Let me just first make sure that we are comfortable with the vector notation. Yeah, so now you begin to get it, right? And now it will be easy. But if you do it for 2 by 2, 3 by 3 or 2 by 2, then it's actually very easy. So that is why that should be done first. So, but anyways, uh, no, so it's a n2 x2, right? This is the vector, so there's no plus. So this is being absent-minded. There's no plus here, commas, and so on, right? This is my second vector, and so on. So there are these, I have these n vectors, right? And then this thing, yeah. So this is my, let's call this v1, let's call this v2, and so on till vn. Okay. Yeah. Then the above thing is the p norm, right? This thing, this expression here, yeah. What is that? Can you say? That is adding the vectors, there are n vectors, adding the vectors and then taking their p. Is this fine? Of ax, yes, yes, exactly. It is just the pth norm of ax, right? That is the above thing. But then we know that this will be less than, and that is, induction on triangle inequality. When you do the pth norm separately, right? Right. So that is just how it is, right? And so we just take the p norm of this. And now you get that, now you can isolate the excise, right? So this less than sign is there, okay? And now it's a nice thing. You see the x2 gets isolated and so on and so on. And so on. Okay. Now what do you do? You should think. Yeah. So just think about this. You can prove that this thing is actually equal to 1. Can you tell me why is this 1? So my claim is that is actually equal to 1. Why is that? It's matrix thing. So what is this quantity? This quantity is A of E1 and P norm of that. Right? Look at it. Or is it not? Yes, that is what it is. Right? If you do A of E1, you actually get the first column. Nagesh, you also know this. Right? we had actually said this last time, right? When you multiply a matrix with E1, which is 1 0 0 0, you actually get the first column of the matrix, right? And you get the so you get the first, yeah, you get the first column of the matrix, right? And then its P norm is this. But why is this 1? Because that should be equal to the Q norm of E1, and any norm of this unit vectors is 1. Okay, so on the unit vectors are sort of they are always going to 1, right? And therefore these things are all 1. And so actually we can do this. Aryan, is this okay? Yeah. Yes. So you should work this out in the 3 by 3 case. Okay. Just sit and work it out in 3 by 3 case. You will see that just the Minkowski's inequality is what you should know that you have to sort of apply. Okay. And then if when these things become 1 and there are mods here, then what do we get? We are getting that this quantity finally is less than or equal to the 1 norm of x, of the vector x, because that is what it is, mod x1 plus mod x2 plus mod and so on, right? So you should know this key thing that we have to sort of write this, then Minkowski's maybe, and then you get this thing, right? But then you know from the start of the discussion that 1 norm is always less than or equal to the Q norm. Right, and so you get that 1 is equal to Q or something. That part we just, yeah, check it, right? So yeah, so what did we say? We said that as the Q, no. Are we doing the opposite or something? Uh, yeah, anyways, that is something which you can, yeah, try for the small case. You can see. Oh no, yeah, I think we were, yeah. There is more. I think problems in there. If yeah, no. So just tell me that. Yeah, so we are getting this, right? Okay. Anyways, let's stop here. Okay, let us stop here. From here, we have one has to work on. This is slightly, yeah, involved question, but okay. But I will suggest that please do this for the small case, 3 by 3 case and so on. Otherwise, you will not know. Okay. So yes, so please do that, and then maybe we can meet on Sunday. And as usual, we'll begin with the questions that you people have. Sunday 8 a.m. Fine, should be fine, right? Or 7:45. Anyways, let's do 8 only. Yeah, 8 is fine. Okay, Sunday 8, and we'll begin with questions. Okay, all right. See you then. Okay.